Hello everyone, my name is Anandakrishnan C M, and here we will be learning about the AWS Fundamentals for AI Practitioner. So it is an introduction to AWS, Amazon Web Services. So you must be planning to take a certification in like AWS AI Practitioner, and you don't have any fundamental information, knowledge, or foundation on AWS. Then this video is best for you. So without wasting any time, let's get started. So how was AWS started in the first place? Like any other startup or any innovation starts, it started from a challenge or a problem. It was a solution to a problem Amazon faced in 2006. Also, the problem was its complex IT infrastructure. So due to its complex IT infrastructure, the CEO of Amazon, that's Jeff Bezos, wanted another efficient architecture change or architecture in IT infrastructure. So the main problem was its complex infrastructure. So it had monolithic systems. So we needed to break down the monolithic system into microservices such that it will improve the efficiency. So there will be microservices architecture, that is authentication databases and like that, and there will be a shared service platform for these microservices. And that is the whole picture in a simple way. That is the whole picture of AWS. So it's a platform that provides these microservices. Yeah, and that is how the AWS was launched in 2006, and like extremely it became the global cloud leader very fast. Like why it succeeded that fast? Because of this pay as you go pricing, easy to access compute resources, like easy to instances everything. And it was extremely popular in startups and enterprises, because we all know it is much cheaper to rent out the resources, to use cloud technologies, other than building a IT infrastructure of its own from scratch. It's extremely expensive, and for that case, it was the best economic decisions to start to use the AWS or cloud technologies, cloud services for that. And now AWS has millions of customers worldwide, and the competitors are Azure, Google, Oracle, like that. Still AWS has an upper hand. um, so yeah, that was how AWS was started. And the need for AWS, we know it was a solution to a problem, that is IT's infrastructure became Amazon's IT infrastructure became that large and complex, and the monolithic code base was hard to maintain and scale. So we needed to introduce a microservice architecture. So the Jeff Bezos initiated a major architectural transformation, and that's how AWS was launched. And the system was divided into focused microservices, as we said earlier. So that means authentication, storage, database operations, like easy to instances and everything. So smaller teams can focus on building much better products. Like since it introduced microservices, we can have smaller teams that get built and deploy features much faster and efficiently. And the main rule or the concept that used was the team should be small enough to be fed by just two pieces. Like since we were focusing on microservices, we only need small teams. The individual teams can focus on that service only, and they can give the maximum output from the service they use. So that was the main idea, and the actual shift was from large monolithic app to multiple microservices, and there will be a platform that shares these services, and that was the start of AWS. And how it how it transformed, how it evolved. Like it built a shared service platform, like I said, that automates the infrastructure tasks. So it simplified like load balancing, provisioning, data center management, everything. We'll have a more detailed explanation of these in the coming slides. And the developers can focus more on coding and deployment other than the infrastructure management. So Amazon realized that others could also benefit from this platform. Like even though they first started, the this idea was emerged from solving their solution. Is what is a solution for their problem, solving a problem they had, but they realized that this could be beneficial for others and they could make it profitable. So it was launched in 2006 with pay as you go pricing. It was really a deal breaker at that time, because you just have to pay for the resources you use as you go. So that is very impressive at that time. And then it now serves millions of customers worldwide. So we all know it's cost effective, scalable. We can if our company is if our uh, startup is scaling, we can scale the infrastructure at the same time, and it's very easy to use, and security is very good. That's why it's trusted by almost everyone. And what is cloud computing? Like in the context of AWS, it's on-demand delivery of IT resources over internet with pay-as-you-go pricing. Okay, that's it. That's all about cloud computing. You are providing the cloud providers are providing IT resources to the customers, to us, over the internet with pay-as-you-go pricing. You only need to pay for the resources that you use. That's very good, right? So the provider provides IT resources over the internet on demand, and no need to own or maintain physical servers or data centers or on-premise infrastructure or anything. Pay only for what you use and when you use it, and access computer power, storage, databases, many different services anytime over the internet. So and main the resources will be managed by we can manage it by three ways, like a console, using an AWS console. Most people will be familiar with the AWS console, and CLI, like we can use CLI, or like we can use the kits SDKs. And yeah, how the cloud computing works. Let's say we all know that we really need physical servers, like we need on-premise hardwares, but it will be controlled and managed by the cloud provider, that is here the AWS. And we'll be using virtualization technologies like hypervisors and containers, dockers, for having VMs, virtual machines. So we will have multiple isolated instances in context of AWS. We will be having easy to elastic cloud compute instances that we can use as VMs for computing or testing, or like for running our programs from anywhere in the world using the internet connection only. We don't need to own the server or the premise hardware or anything. You just can use it. So that's the main thing, and multiple users can share these resources. So very securely. So that was the main deal breaker. And the access methods is like I said earlier, there's AWS management console, there's command line interfaces, like you can like the terminal, and then SDKs, there's development kits, and available anywhere at any time. And the main core technologies are, as I said, there's hypervisors, containers, like manages the virtual machines, and lightweight isolation, that is dockers and everything. And multiple users can share the physical hardware simultaneously, and resources will be isolated and secured. And now we know that what are the benefits of cloud computing. We already know that you only want to pay what for what of the resources that you use. So it will be low cost and scalability. As I said, it's on demand. You can scale up uh, whenever the startup is like scaling. You can also scale the IT infrastructure is on demand. And global reach. Data centers are worldwide. There are dozens and dozens of availability zones, the AWS regions everywhere, all around the world, all around the globe. So it is the availability is that good, high availability, security, using IAM. IAM is a very important concept in AWS, and we'll be explaining more about that in the identity access management. Then we'll using encryptions, firewalls, and the security of the cloud will be there. So innovation focuses mainly on apps, not on infrastructure. Like the solution for the problem we had, we don't have to waste any time managing the infrastructure. We have to focus mainly on the innovation, that is the development. So that are the benefits of cloud computing. And these are the advantages. It's the same thing: low cost, scalability, global footprint, the data centers availability zones are all over the globe, high availability, security, and innovation. And now let's understand which are the models of cloud development models. Okay, like there are three types of cloud development models. There is public model. It's very simple. What do you mean by public model? It's infrastructure managed by cloud providers. There will be multi-tenant. What do you mean by multi-tenant? There will be much more than one company, or more than two or three companies in the same cloud. So that means it will be lower cost and high scalability options will be there. And what about private cloud? Like the name suggests, there will be only a single tenant, that only one organization will be using that cloud. So there will be much more control and security for privacy, for suitable for regulated industries like healthcare, finance, and everything. You will be needing private cloud other than the public cloud. And hybrid cloud, so it is a combination of the best the good things from the public as well as the private cloud. So it's a combination of public and private cloud, flexible balances. It will be much more cost effective in comparison with the private cloud, and security and performance will be also there. So let's understand what is public cloud. As I said earlier, this infrastructure managed cloud providers and multi-tenant model will be like that. What that means, shared resources by different clients. That's the main thing. The main providers are, as we know, AWS, Azure, and Google Cloud, and even Oracle or whatever. So the benefits are it's lower cost and high scalability. Like we all know, we are sharing the same resource, so the low cost will be lower, and no infrastructure management will need to be done. No overhead of that, and also security using IAM encryption complaints security is also there. But still, you will be needing private cloud single tenant model for some industries like healthcare and finance, where confidential data matters, confidentiality is that must. For that cases, you will be needing single tenant model. There's a private cloud. So organization controls and manages all infrastructure. So that means it's highly customizable to meet the specific needs of that particular company or organization. But that means greater security and privacy controls, full control over the infrastructure, customization, freedom, compliance, everything. But what are the the disadvantages, cons of private cloud? Like it's extremely expensive. Like you will be having your own cloud infrastructure. That means you will need dedicated staff for managing that, and also the cost in that cloud itself will be managed by you. So it's much expensive in comparison with the like the public cloud we discussed just earlier. So what about hybrid cloud? There will be some cases where they will be having some confidential information, very important confidential information, but as well as we will be having some general information. So we can use both these. We can use the goods of both these cloud technology, cloud concepts, that is private as well as the cloud, as well as the public. So for specific important information, confidential information, we can use private cloud. Okay, and for other information, general information, we can use the multi-tenant public cloud. So in that cases, we have to use the hybrid cloud. That's it. So it's a combination of the public and private cloud, and it enables data and application sharing between clouds, different clouds. So that means it's a multi-cloud environment, and like we have the private cloud and we have the public cloud, and we will be using every cloud for our day-to-day operations. So it balances the flexibility, security, and cost. It's much more cost effective, but still it is it is a bit expensive in comparison. And example for is outpost. You will be learning more about outpost in the coming classes. And the benefits are, like I said, it's greater flexibility, improved disaster recovery, better workload distribution. We have private confident we have a private cloud for the confidential information, as well as general information we have public cloud. Like that, it's more complex to manage. Like even while I was saying that, it sounds complex, like we have some for this, we have some for that, but how it is overall, like how is it managed? Like we should have a team, a dedicated team for the private cloud, and but in the public cloud will be managed by the cloud provider. So it's a bit complex. So that's one of the challenges you will be facing while opting for hybrid clouds. And an example for that is AWS outpost. And yeah, this is it. This is the comparison. We will have it. We can have a take a look, a simple look at that. It's multi-tenant and single tenant, and this combination of that, and provider managed will be by the management itself, and it will be managed by the organization. That means high control over that, and it will be shared, and cost will be as you go extremely low. Public cloud is the most cost effective cloud model that you can select. And in the private, as you can see, it is extremely high. Infrastructure cost is very high, but in the case of hybrid, it's balanced. And the security, we can own that the private is much higher. Both others are okay, and scalability excellent, limited scalability, because you can understand that it's a private cloud. And flexibility, in the case of hybrid, it's extremely flexible. best for web apps testing, that's public cloud. Finance, healthcare, you have confidential information, so that's private cloud. And hybrid cloud for mixed workloads, special organizations. And now we know what are the models, like what models we use in cloud. So now we understand what is the service types, like we are all familiar with as a service, like infrastructure as a service, software as a service, platform as a service. Let's understand what is the service types provided by the cloud. As a service means renting IT capabilities instead of just owning them. Okay, you're just renting it. We are all using software as a service even right now. You too. So what are the services provided by cloud? Infrastructure as a service, we'll be using VMs, virtual machines, storage and network. We'll be using the infrastructure of another that is provided by another provider as a service, that is infrastructure as a service. Platform as a service, we'll be using platform, that is as well as the infrastructure with middleware and development tools for analysis analytics, for making it much efficient, much better, much easier, even though we won't have much as much as control we had in infrastructure as a service. And we have software as a service, we'll be using ready to use applications via browser or anything. So it's let's understand a bit how the service types are in AWS. So first of all, infrastructure as a service. Like I said earlier, it provides core IT infrastructure as a service. That means virtual machines, storage, networking, all that. The example of virtual machines, EC2, Amazon EC2, Elastic Cloud Compute, and user manages the operating system and applications in that instances, offers maximum control and flexibility. We'll be using a specific, like we'll be using an instance, we'll be using a VM. So whenever we have to test or run a product or an application or project, we'll be using EC2 instances, and we will have maximum control over the and flexibility over that. So but at the same time, we'll be have to manage the resources, and also the security patches, also everything in the OS that is in the instance. And the use case is that it's a creating testing environment for an application. Like I said, if you want to test a particular project or a development that we have done, we have to spin up easy to instance instantly. So that's an example for infrastructure as a service. What about advantages? Yeah, the advantages is that the full control over infrastructure, highly customizable environment. Like we can customize how much resources we want for that particular project or that particular testing, and it's a scalable resources are needed. And challenges, yeah, like we know, IT expertise are needed to manage it. Like I said, the security patches, OS management, everything, and cost management is critical. Like as I said, easy to use. Like if you turn it on for much time, it will be much expensive. And risk of vendor locking, if we are currently in using an AWS like infrastructure as a service, if we want to switch to Azure, that is extremely that's very complex, that is very hard. So that's risk of vendor locking. You have to locking the provider, cloud provider, before anything. So platform as a service. What do you mean by platform as a service? It includes the infrastructure as a service as well as the middleware, the development tools and the softwares that is here, that is between the infrastructure and the development. Let's see, it uses databases. What it provides is databases, authentication and load balancing. That means monitoring, analytical tools will be here in platform as a service. That developers focus entirely on building applications. Okay, they don't need to focus on the infrastructure, they don't need to manage infrastructure like infrastructure as a service. They just need to focus on the building applications. But even though there is flexibility, right, there is much more flexibility when comparison with service, software as a service. And examples for the platform as a service are SageMaker, Jumpstart, or Elastic Beanstalk, like that. So we'll be learning more about the services in the coming slides. So benefits is the faster development cycles, lower operational costs when comparison with the infrastructure as a service, and integrated development environment. Yeah, like we know, like there the provide the what are those services provided, databases, authentication, load balancing, and reduced infrastructure burden. That's very good. So what about the software as a service? Software as a service is that cloud providers manage everything end to end. Everything end to end. We are all familiar with Gmail, Google Docs, Slack, or anything. We are familiar with these applications. We are using software as a service. So users simply access and use the application. That's it. Nothing to manage, nothing to, no infrastructure, no platform, no any data analysis or anything. So you just have a subscription based pricing model. You have a subscription for that application, and you use it as a service. You use the service software as a service. So it's completely the cloud provider manages everything end to end. And this is the comparison between those three, that is infrastructure, platform, and software. So user management, always an application should be managed by the infrastructure, right? Infrastructure, like the IT, there should, we should have IT resources for that, IT personnel for that. And what about the PAs? Like platforms is applications only, like you don't need to manage everything hardware in the hardware, or like where we were using easy to instances or anything. In software as a service, nothing. We already know that you just have to use everything will be provided by end to end by the cloud provider. And control level high, medium, low, we all know that flexibility, like high, moderate, limited, like limitations are there. And AWS example in AWS concepts is the EC2, elastic beanstalk, say SageMaker, Amazon Q, workloads. We'll be learning more about this in the coming slides. And best for infrastructure control, we should have, if we need huge infrastructure control, we should be using infrastructure as a service. And for app development, it will be much easier to do platform as a service. And end users, we will be using software as a service as of now. But after we have learned more about AWS, we'll be using all these two also. So yeah, what about the global infrastructure of AWS? Like as I said earlier, there's regions, AWS regions, availability zones, and local zones. What do you mean by that? Geographical areas. Like for example, like while we are signing into AWS console, we'll be seeing an URL right there, and while using a browser, we'll be seeing US East 1 or EU Central, or if you're from India, like Mumbai or Hyderabad. So these are the regions, like geographic regions where AWS provides the services. Like, and the availability zone, multiple data centers per region with redundancy. We will be learning more about that. Why do we need multiple data centers in the same region? We will be learning that. And local zones, closer to the user for ultra low latency workloads. We all know that much local zone that is the most closest to the startup or enterprise, it will be much faster and cost effective to the enterprise. First start about first start with AWS regions. Key points is that it's a region, it's a geographic area containing AWS infrastructure. That's it. That's the main point in AWS regions. AWS operates across dozens of regions in worldwide. Like I said, example like US East or Europe Central, or like I said in India, Mumbai, Hyderabad, and regions are fully isolated from each other. Like we all know, these are we have, even though we have dozens of regions, is completely isolated. And choosing a region is very important. Proximity to US. If you're currently in India, we cannot use it will be much. It won't be very effective to use AWS region that is located in US East. Have to be used by providers, by the startups and enterprises who are in US. So proximity user is a component, is a gap that you should consider while choosing a region. Compliance requirements, like I said, in some countries like Switzerland, the country will have some complaint requirements if they are dealing with healthcare related information data, healthcare data. It cannot pass, it cannot travel from that country. It should be within that country itself, should be stored within that country itself. So then shouldn't have that campaigns requirements are there. So while choosing a region, we should have to consider that too. And service availability, some regions won't have this all AWS services. Some will have some will have others. So we have to understand what services we want, and we have to select the AWS regions according to that. And cost differences, yeah, that's very important. There will be much difference between the cost that will be in like US East and Mumbai or Hyderabad in comparison. So and that's all about regions, AWS regions. And let's see about availability zones, AZs. What about like you can see the AZ1, AZ2, AZ3. What is there are DZA, DZB, like what is that? Data centers. We will have multiple data centers in the same availability zone. Each AWS region contains multiple availability zone. So it's, if we are looking at a superset of this AWS regions, we have like multiple AZs, and in that AZ we'll have multiple data centers. That's it. Each consists of much or more, one or more data centers. AZs have independent power, cooling, physical security, that is a wall infrastructure itself connected through ultra low latency networks, and improves reliability, fault tolerance, and heavy availability. That's why we need multiple data centers for improving the reliability and fault tolerance. Or if any catastrophe happens, we should have another backup. That's why. And local zones. Local zones are extended AWS services closer to the end users. That is the most closest to the end users. Designed for ultra low latency applications. Like if you are gaming or using VR or AR workloads or video streaming, we should have ultra low latency, and that's when local zones are should be focused. So supports data residence requirements and enables hybrid cloud environments. Like I said, we already know what hybrid cloud requirements are: multi-tenant, shared resources, shared multi-cloud share, and use cases are video streaming, gaming, virtual reality, AI, ML, everything. And AWS pricing models: pay only for the resources you use. You choose the model that fits your workload. That's it. Let's understand that. On demand. On demand means pay by the second or no commitment. Great for testing and variable loads. If you are testing a program, then you should use EC2, and that's it. You should be only paying for the time that you use that resource itself. And saving plans, there is no commitment on demand, but in the case of saving plans, we can save up to 72%, but we should have commitment. We should be using that service for 1 to 3 years. And dedicated host means servers, physical service for one particular customer, like the private cloud model we talked about, support license, complaints, everything. And there will be support instances, use a spare AWS capacity. Like if there is an unused AWS service resource, we can have discounts up to 90%, may be interrupted. Okay, let's see how it's like. We will have a 2-minute notification, but let's see, we will having much more explanation on that. So here, on demand versus saving, and savings. On demand means pay for compute capacity as needed for the things you use, no long-term commitment, and suitable for testing development, as I said. And in savings, we have commitment for 1 or 3, but it's savings up there, like I said, and the examples for that is EC2 instance saving plans, not EC2 instance involved. See, EC2 instance savings plans and compute savings plans. So yeah. And dedicated host and sport instances. What's that? Dedicated host means physical service dedicated to one customer. It's only so the private cloud concept that we are talking about, and suitable for regulatory requirements. Everything is it's single tenant applications like healthcare, finance, etc. Sport instances use unused AWS spare capacity that discounts up to 90% off on demand. If you need it, we can use the unused AWS spare capacity, but can be interrupted by AWS within 2-minute notice. We will only have 2-minute notice, and it will be interrupted. So that's the main problem we will have. So best for batch processing, big data, or continuous integration or development, like that. So this is the comparison between them. And let's say this is the main last topic that we'll be focusing today, and this was the main topic that we had to focus today. That is the services provided by AWS. There are more than 200 services provided by AWS, but we'll be focusing on the core services provided by AWS here. We'll be focusing with connection to context with a scenario that is building a food delivery application. Let's see, when we are building a food delivery application, we will be having user registration. We have to list the restaurants, we have to process the orders, the menus, and real-time tracking should be there, and analytics and recommendations should be done for future improvements. Let's see, we can see so many Amazon names and all these service names. We will get much familiar with them in the coming classes, but in today's classes we will be having brief understanding of what these are. So let's see, data collection and processing is the first step in if you are building a food delivery app. Let's say Amazon S3 simple storage service. Amazon simple storage service 3. And what does it do? It stores restaurant images and menus. It stores the customer data and order records, and it's durable, scalable object storage. Like it's the hardware, like it's like using a hard disk or something like that. Like we have to store these informations, that general informations, and that will be stored in Amazon S3. What about AWS Lambda? Like it processes orders automatically. It sends notifications to the user, updates or the status in real time. Like if the user are using, if you want to place an order, it retrieves the data from S3, and Lambda will send a notification to the user, and we'll be using Glue. What is Glue? AWS Glue. It cleans and transforms the collected data that is collected from S3 and the real-time data that is collected here, and it prepares data for analytics and ETL jobs on schedule, that is extract, transform, and load. and the data analytics concept, and it should be those ETL jobs will be on schedule. That is AWS S3, Amazon S3, AWS Lambda, and AWS Glue. We'll be learning much more about a Glue and Lambda in much classes, and S3 we already know what it is. And next time, real time, these are storage and databases. This is real time, this is transaction, and this is analytics. Let's see. Real time is DynamoDB. We are very familiar with DB databases, and stores real time ordering tracking data, and it is fast, low latency, no SQL, no structure, no SQL accesses, auto scalable throughput. But in the case of transactional, Amazon RDS stores customer accounts, manages orders, payment. Like these are the more important, more like transactional order payment informations that manage relational. That we need relational databases. That is RDS, relational database services, Amazon. So we will be needing Amazon RDS other than the DynamoDB, where DynamoDB is useful for real-time storing and everything. In the case of Amazon RDS, it will be more focusing on transactional things that will be needing relational databases. And analytics, Amazon Redshift, that analyzes the customer behavior, tracks popular restaurants, and reveals sales trends. That is very important if you're planning to start, if you're planning to make any app or even for delivery or anything. So in the next is compute and content delivery. Compute, we all know what service we need for compute. That is EC2, elastic cloud compute, EC2, and it runs the recommendation engine. We can run the recommendation engine, we can handle application workloads, and it's scalable virtual compute. We can have more instances, and also we can improve the requirements of the EC2, right? So there's a fast performance. And what is EBS? So in Amazon EBS, it's persistent block storage for particular is like EC2, like elastic block storage for what EC2. It stores application data and automated backup snapshot, the scalable infrastructure. And CloudFront CDN, what does it do? It delivers restaurant images and menus, caches the content, and it is extremely important. This CloudFront is extremely important, and it's also very expensive. It reduces the latency globally, so it's better. It improves the user experience by exponential scale. So yeah, monitoring login. Last thing is monitoring login. That's CloudWatch. Amazon, we should use Amazon CloudWatch that monitors all the AWS resources in real time. That means tracks the EC2 use, like CPU usage in EC2, and application performance, errors, everything, and send alerts and notification whenever an issue occurs, and helps with debugging as well as troubleshooting. So it is very needed for reliability, security, and speed. And let's see, what are the services provided AWS by the AWS. Let's see, AWS services, we just learned a brief of these things. And in the scenario, like we are starting a delivery app, for delivery app, let's see, let's say S3, that storage stores the like an hardware file and object data storage. Lambdas, like it's automation, like sends notifications, serverless event driven processing. Glue, that is data transformation, ETL, extraction, transform, and load. And DynamoDB, that's real time. Amazon, that's transactional. RDS, that's transactional. Then Redshift, that's warehouse analytics, that's very important. And EC2, that's computation. And EBS, that's for the storage for EC2, the position block storage for EC2. Then CloudFront, that's for the delivery, that's very important. And CloudWatch, that's monitoring, logging, and alerting of the cloud. And that's it. Then another very important concept in AWS, that's the shared responsibility model. That's, as I said, there's a responsibility for the cloud provider as well as the customer. So here we can see security of the cloud. Security of the cloud will be the responsibility of the AWS or the cloud provider, but security in the cloud, that will be the responsibility of the cloud customer or the stakeholder. Let's see, it's a physical data centers. In the case of AWS requirements, AWS responsibilities, it's a physical data centers, hardware, network, global infrastructure, managed server services infrastructure. But in the case of customer responsibilities, the data protection, the user which users have the access to this data and how it's managed, application security, OS configuration and process, it will be the responsibility of the customer. So AWS secures the cloud. It secures the cloud, the whole cloud, but customers have to secure what's in the cloud. The data should be the responsibility of the customer. And the customer responsibility, let's see, in the customer responsibility in like infrastructure as a service instance, for example, customer manages the operating system management. Like I said, security patches, you have to have an IT resource, IT people for that, for managing these things. Configure security groups, project application, protect applications and data. For that, all these things will be managed by the customer. And SaaS, manage the user access and permission, protect data, and apply encryption. So that is it. The services are IAM, identity access management, for key management, CloudTrail for logging and monitoring, configuration. That's a resource configuration, monitoring, trusted devices, security, and best practice records. These are just like a brief explanation of that, briefing of the services, but we will have a much more detailed explanation in the further videos. Yeah, AWS IAM, identity and access management, manages authentication and authorization. What is meant by authentication? Authorization, who it proves who you are, and authorization, what you can do, what permissions can you do in the AWS, and controls who can access what. So this is there are three concepts. That is IAM user, IAM group, IAM role. So what is IAM user? This is individual person application system with credentials, that who uses it, who can manage it. Like we can group these particular users into a subgroup, that is IAM group, that we will have a collection of permissions policies for that particular group. So we can just add that particular, if a new user comes, we can just add them to that particular group. Like if a tester comes, we can add that tester to that particular. If a developer comes, we can add that into a developer group. But if you want to have a temporary, if you have to avail a temporary permission to a particular user, a particular IAM user, then we should use IAM role. Temporarily we can give the permission, and that is the main thing. Like you only have to give the permissions temporarily, because the principle of least privilege gives that give only the permission required for the task, nothing more, nothing else. Like we should only give the permission required for the task. And IAM security policies like MFA, that's very famous, multi-factor authentication. We should have another layer of security using a password or any authentication software, app, and IAM access analyzer that detects the unintended external access, helps improve security and compliance. And the IAM policies, that the policies are also too, like identity based and resource based. The identity means the attached user group or roles, define what actions they can perform. But resource based policies means attached directly to resources. Like if a particular S3 bucket, we will have some policies to that is related directly to the S3 bucket, that control who can access the resources. So yeah, we can have identity based and resource based. Some permissions will be only available in that bucket only, S3 bucket only, and here that user will have some kind of permissions that will be only for that particular IAM user, and here particular for that particular resource. So user IAM policy and AWS resource. So that's it. Then this is all about the AWS free tier. That's 12-month free tier. Now it's 6 months, and one like that the informations are given: 5 GB S3 storage, simple storage service, and like a monthly RD as well, relational database services we use, EC2 instances we use, and it's always free. 1 million lambda requests per month. And we can even run a simple software there, and 25 GB DynamoDB storage, and there is no expiration data. There is no expiry. So short-term trails are limited time free offers available for selected AWS services. Like we have to be very cautious by selecting AWS services, because some of them are extremely expensive. Like I said, the cloud front. So check AWS console for current offers, and yeah, you have to. And exceeding free tier limits results in pay-as-you-go charges. Like the monitor usage in the console, you have to click that notification. Like you should be aware of that whenever you exceeds the free trial limit. And yeah, creating an AWS, I can also do a short video, brief video, how we can create a AWS account. If that is not very necessary, because it's very simple. We just have to go to the Amazon website, click on like AWS, create an AWS account. It will write somewhere right here, and enter the account details and everything, account name details and everything. Then provide personal information. If you are starting from subject for learning, then should be opting for personal, and add credit card, debit card information. You should use master or visa card, otherwise it won't complete, it won't be and you can use all services of the AWS. And you can have to verify the phone number. Then support plan, that's basic. If you are learning, we should have a basic free basic support plan, and don't use development or something, developer plan or something. It will be you have to pay for that and sign to AWS management console. That's it. And these are the takeaways, the key takeaways of this video. That is, we have a fundamental understanding of cloud computing, what is cloud computing, and how it was launched, and what are the models. Three models: private, multi-tenant, single tenant, and hybrid services, like infrastructure as a service, platform as a service, software as a service, all that. And AWS cloud, AWS global infrastructure regions, AZs, local zones, AWS regions, everything, and pricing models, on demand, savings, everything, and the core services on context of building a the food delivery app, and responsibility model, that's the responsibility, the safety on the cloud and in the cloud, like off the cloud and in the cloud. And the off the cloud will be done by the provider, cloud provider, and in the cloud will be with the responsibility of the user or stakeholder, or the client. Yeah. Then AWS IAM, identity and access management, is very important, and how it's managed IAM user, IAM user role and groups, everything about that. And AWS free tier and account setup, like how to set up a free tier account, and what are the what are the resources we can use in that. And scalable, secure, cost effective cloud services for modern applications. That's it. And yeah, this is a simple question I can provide you. This is the answer key of that. You can check it out in the description. There will be a doc for these questions. You can try it out. And thank you so much. And yeah, my name is Anandakrishnan C M, and this is my first video, so there will be some mistakes and some issues with that, but I will be improving that in the coming videos. And we will be having a complete course on AI Practitioner, on AWS AI Practitioner. So thank you so much. Have a very nice day. Thank you.